Hi, I'm going to be talking today about core implementations. Hopefully you can all see my screen. This has been a big year, as Molly kind of talked about. DHT, obviously a huge thing there, but so much else went on. Going back and just reading through the blog to see where we were at, I realized that like earlier this year, let's see, the async await refactor landed in JavaScript, which was a huge undertaking in 2019. It took a very long time, and usability there was huge for JavaScript. One of the biggest things for me personally is debuggability that helped improve. I don't know if you've worked in the JavaScript environment before in JS IPFS or libp2p, you might have seen these like nightmare stack traces trying to debug what's going on. That has improved a lot just because of the refactor here. And what's nice is also in that part of that release of that, we did a big reflection on what does it take to do a large refactor like this? What did we do wrong? And so you can check out that blog post on big refactors there that Alan posted earlier this year, and try to avoid doing these large things in the future. But we definitely want to make sure that we're doing refactors as we go. From there, another thing, a big goal in the first half of the year was to work on developer improvement in addition to improving the DHT or developer enablement. And one of the things that JS IPFS has done really well this year is streamlining that release pipeline. So now every merge to master is in RC, so you can npm install next and always get the latest and greatest and test that out. With that, we've also really this nasty mind map of repositories going on here. Getting a feature change out the door sometimes would take PRs across multiple repositories, and those would all have to get landed together, and it was a nightmare to deal with. We've really coalesced a lot of that to make it easier in the IPFS repo, and now we've kind of been able to release a lot of those dependencies altogether, kind of moving to a mono repo for all of those things that don't really make sense to be separated. Then DHT and bit swap improvements. So really all of this stuff from 0.5 through 0.7, so much work went into this. We'll kind of talk about the DHT performance improvements a little bit more, and then bit swap as well. But this was a huge undertaking that took a good part of the first quarter, well into the second quarter, and then we've had a trickling of updates since then. So talking a little bit about the DHT and bit swap improvements. So the DHT, right, was not very performant, and I'll kind of walk through some of these initial metrics here. So what we did is we got together with TestGround. As TestGround was being built, we were kind of doing these things in parallel, which was really huge. And here you can see kind of some of the TestGround benchmarks that we put in place. So these aren't based on the live network in this. This is everything that we've pulled directly from TestGround. So we've had huge gains in Go from IPFS 04.23 to IPFS 0.5, and it's continued to get better. Such significant improvements there. So a lot of work, a lot of benefit. It's been really great. Looking at these find times over time, like finding content on the network. So we go back to IPFS 04.23. It's probably hard to see here, but in the 95th percentile, our find times were at 45 seconds. And so this was like, we were running this, our metrics are being collected on the live network. What we do is we have a cron job where we will spin up some nodes, we'll provide some content, we'll query the content, and this is where this is coming from. This is coming from the live network. We're not pulling from other people's queries at this point in time. Because privacy, yay. And so in IPFS 0.5, it was a huge gain coming from 45 seconds to an average about 5.4 seconds week over week. In 0.6, as we continue to make like tweaks and improvements, and as people just upgraded the network, like the big gain here from 0.6 to 0.7, going from 5.4 to 3.8 to 1.5 seconds, like we're seeing pretty consistently 1.5 seconds and 100% success in find time. This has just been because people are upgrading from 04.23 to 0.6 and 0.7. So tell all your friends, upgrade, get the latest. Bit swap improvements also, as part of a collaboration with Netflix, one of our engineers, Dirk, was working with them to work on transferring data within their transferring containers around. And so we worked on bit swap improvements to improve the ability when you have multiple seeders. So here on the left, you can kind of see some graphs of the various levels of previously in master, which was our old bit swap, and then the POC, which is now live. You'll see that when you have more seeders, it's now much more effective, which is really, really great. And additionally, in JS IPFS, like such big gains there in data transfer speeds. Like you're looking at, over 50% gains in throughput there for just doing some small tweaks. So really great stuff. Molly talked a bit about hardening. This was a big focus this year. Obviously, large networks, ETH2 launching this year, Filecoin launching this year. Like it's very important for these networks to have a lot of integrity. And so with that, we took two endeavors here. One is Gossip Sub 1.1. And so we spent some time, a lot of thought went into this with the libp2p team, our research team, working with our collabs to figure out, what do we need to do to make this hardened and secure on the network. And so working with TestGround again to test out attacks, go through various hardening techniques. You can read more about it in the blog post. A lot of improvements there, and we were able to land that in both Go and JavaScript, thanks to the folks at ChainSafe landing in JavaScript. So that's huge wins there. For the DHT hardening, you can kind of read about this blog post, but we some researchers reached out earlier this year and was like, hey, we found some vulnerabilities, and we collaborated with them for the 0.5 release. Like it actually used to be fairly easy to eclipse a node and evict people from the routing table. Now that's significantly harder. Again, we leveraged TestGround to do this, and we actually ran some 24-hour attacks against some of our own bootstrap nodes without any consequence, low eviction rates. It's been really great. So awesome stuff there. Then noise, quick, and more. So yeah, we replaced SecIO with noise. Noise is in all 7 implementations of libp2p. It's the standard protocol for the ETH network as well. Big wins there. Switching over to Quick has saved us in round trips, which is why you're seeing additionally some improvements there in the DHT query times, just reducing the amount of latency that we have in backbone connections. And then a whole slew of other stuff, custom DAG formats in JS IPFS. You can now peer nodes in Go IPFS, which has been super valuable for clusters. And then last but not least, something that we're working on right now, JS IPFS has already released this pinning improvements. So moving pinning into the data store out of the DAG, you can see here kind of in this graph of where JS IPFS used to be, this blue line on top. The more pins you have, the slower and slower it gets. Go IPFS is the yellow line in the middle. After the fix, JS has been level. And the Go IPFS 0.8 RC is out. It just launched this week. So if you want to test out the pinning service performance, please do. We would like to make sure that is fully functioning before we fully release, make sure everything's good to go. We've done testing on our end, testing out our services. We want to get as much testing there as possible. And then I think Lyda will probably talk about this a little bit later on, but remote pinning services are going to be landing. And this is going to be really valuable for people who want to leverage services like Pinata or Infura to be able to offload, say, hey, can you hang on to this for me? You'll be able to configure remote pinning services in Go IPFS, and JS IPFS will also be releasing with this. And what that'll let you do is those services can then pin it on your behalf, and you can do that directly from the IPFS clients. So again, this is in the Go IPFS 0.8 RC, so feel free to play around with it. And I think that's it. Don't forget to update. Don't forget to upgrade. When 0.8 comes out, upgrade. And thanks, everybody.